Hi everybody, I hope you've had a great day. Today we're just going to look at the concept of finding the area. Now in the previous video we looked at this concept where we had a function and then you had it bound by the x-axis. Alright, so for most of these, if you're above the x-axis, simply is going to be the integral of f of x. It's technically f of x takes 0. Now if it's below the axis, that's why we will have something like 0 take the f of x. Just go on to the next bit of terminology and we'll show you that in terms of an example, how that works. Alright, so the next concept is what happens if you have an area bound between two functions? Well, the rule is basically that it becomes the top function take the bottom function for that region. Since we're going between A and B, right, so we'll need to find those intersect points with doing that. And we can do that algebraically or we can do that on our graphics calculator. And then we look at the top function. So in here the top function is in fact f of x. The bottom function is g of x. So therefore it will be an integral of f of x take g of x. Well, let's do some examples anyway, and I think that might help you understand what's going on. Oh, that looks a bit dodgy. So here, what we've got this thing over here is bound by the x-axis. So we want to find the area of this particular function bound by the x-axis. Now, if we graph that, you'll find that our graph goes a little bit like this. Right, so it goes up like that, down like that, and then up like that. Alright, so what you'll have here is you'll have this area here. When you integrate that, that will be a positive area, and when you do this area here, that's going to be a negative area. So if you did the integral from all of that, what's going to happen is you'll get the red bit take the blue bit, so you'll get a negative area as your answer. So if we want to find the actual area, what we're going to need to do is we're going to need to break this into two problems. All right, so the area that, let's call this function here f of x. All right, the top function here f of x is there. Here f of x becomes the bottom function, doesn't it? Right, so really what we need to do is from this point here, which is going to be, we'll have to actually factorise that to find the points, and then we'll actually be able to tell you where that goes. Alright, so let's, first of all, the first step is we need to factorise this particular function here. So we need to know when that's actually equal to 0. So we've got x cubed take 4x plus 4x squared plus 3x, and we want to make that equal to 0 to factorise that. Bring in a common factor of x, that will leave us with x squared take 4x plus 3. Alright, and then I can factorise that again using the quadratic, and that will give us obviously 3 and 1, and then negative and negative. Now they don't always have to work out as neatly as this one here, but I've made this one up. So now you can also go to your polysim and do that on your calculator if that makes it a lot quicker for you. I highly recommend that. So what we've got there is obviously x is equal to 0, 1 and 3. Alright, so this point here is 0, this point there is 1, and that point there is 3. So that gives us an idea about how we have to set our integral up. So the integral that we'll be setting up will be 0 to 1, and that's going to be our top function take our bottom function. So that would be f of x take 0 dx. Now we don't normally write the 0 in, alright, but this is crucial when you do this next bit, which is the integral from 1 to 3, that's going to be 0, because 0 is now our top function. Take f of x dx. Alright, so that's how it sets up, so you can get the actual area bound by that thing where you don't have to worry about or you take into account the negative bit because it's below the axis. So let's do the integral of that. So that's equal to, from the integral from 0 to 1 of x cubed, take 4x squared plus 3x dx. Now I could also, rather than put the negative through the whole thing, if I just said take the integral from 1 to 3 of x cubed take 4x squared plus 3x dx, that will do the same thing. Alright, so now let's go and integrate that. So that's an easy integration. So we've got x to the 4 all over 4, take 4x cubed over 3 plus 3x squared over 2. And so that goes from 0 to 1. Now we're going to take the answer of the same thing again. Alright, it's a no-brainer, don't have to think about it too much. Do this as quick as you can. Is a good thing to do. And that's going from 1 to 3. So we need to actually do the working out. So that's going to be, literally put that in there. It's going to be, I'll get rid of the square bracket, make it a round bracket. Alright, so that's going to be 1/4. Take 4 on 3 plus 3 on 2. That bit over there. That's going to be take 0. Now I'm not going to worry about putting the 0 in there. The next term is going to be, and we probably should keep this in a bracket. Alright, so the next bit's going to be 1/4. Sorry, it's going to be 3/4. It's not going to be that. It's going to be 3 cubed, 3 to the power of 4. So that's quite a big number. So 3 squared is, well, 3 to the power of 3 is 27. So it's going to be 81. So 81 over 4. Right, 3 cubed is in fact 27 times 4 is 27, 80, 108. So that's going to be take 108 on 3. Right, the next bit's going to be 3 squared, so times 3 is plus 27 on 2. Right, and then you're going to do the same thing over here, which we had before, and that's going to be take 1/4, take 4/3. Right, and we have to put that in a bracket, and that's going to be plus 3 on 2. Right, so you get the idea of what we're doing there. Now, the whole thing from that part is you can actually do that on your calculator if you need to. Alright, so if we start looking at this particular function here, alright, we could do it that way, but I'm going to show you an easy way of doing it, and I think this will save you some time. So if we go to our calculator and we put in the function that we've just been working with, so that is in fact x cubed. Alright, take 4x squared, and that was, what was it, plus 3x I think, yeah, plus 3x. Alright, so if you put that into your calculator and you graph that, right, you can see obviously that matches what we were looking at before. And if you use your calculator bizzo, right, so then what you're going to have over here, right, because you've got a calculator, I mean we know you've got that in there, so we're going to save some time. So lower limit there is 1, 0, upper limit's 1. It will work that area out for us, which is 0.4167. Just to save time, equals 0.416, well, let's go 67. Alright, and then you can do the area, the other bit. Alright, so that will be obviously this whole thing over here, when we're looking at the area of this section. So you can go over here and do the same thing again, calculate You can go down to number 7. You can go from 1 to 3. It will work that area out there. That's actually negative 2.677. So going back to your question over here, right, so that's going to be negative. So when you add it on, it's going to be plus 2.667, and so therefore adding those two values together, you can actually work it out. Now that's not going to be an exact answer. If they want an exact answer, then what I suggest you do is put this in on your calculator and do fractions. Now, I just want to sort of move on so I can get on to the next question, but I think that gives you a bit of a guide as to what to do. If you were looking for a lowest common fraction, obviously 12 would be the number that you're looking at there. Again, 12 will be the number, so you're looking at some sort of number over 12. Alright, so just in mode for time, I'll keep going with the next question. Alright, so this one here is looking at the area bound by these two curves. Alright, so if we look at that question, then we're considering obviously an intersection point. So we need to know where these two things intersect. So that's our first step to actually do. So they meet when they have the same y value. So they meet when x plus 4 is equal to x squared plus 2x, take 3. Alright, so if we bring everything over to one side, we can say x squared, that's going to become over there, take, so it's plus x, bring that across, that will become take 7. Is that right? Yeah, that will be take 7. Was equal to 0. Right, so we're looking for factorising that, and I don't know if that factorises easily. I thought I set this up so, oh sorry, that's not the right function. Over here that was supposed to be plus 3. Alright, so make that plus 3, plus 3. Alright, so when that comes across, that will be plus 6, take 6. So therefore this function here is going to be x. Obviously you're going to have 3 and 2. Alright, so x and 2. And then we're looking at obviously the positive, so that's going to be plus 3 and take 2. So therefore x is going to be equal to minus 3 and 2. Alright, so they're the two intersect points for that. It's probably a good idea at this stage to actually graph this and actually see what we're looking at there in terms of our function. So I have put those into our calculator. We'll just delete that there, and we'll highlight these two things so we can graph them. Alright, so if we graph that, so again this is the quick way of doing the intersect point. So you can see that would correspond to at 0 and being at negative 3, and that corresponds to the fact that intersecting at 2. So you could do that graphically on your calculator, and that would be equally okay to do that. So really what I need to consider here when I'm starting to look at my function, what's the top function? Well, the top function is in fact x plus 3. My bottom function is the quadratic that we're looking at there, and I'll be integrating across from negative 3 to 2. Okay, and if I do that, then that will give me the answer. So let's do that right now. So that's what we're doing. So we need to do the integral of negative 3 to 2. Our top function is in fact x plus 3. Take our bottom function, which is in fact going to be the quadratic, which is x squared, plus 2x, take 3 dx. Alright, so that's what we need to do now. You can simplify this by taking your negative through the bracket, and we can say that's equal to, from negative 3 to 2. Alright, so it'll be x, take 2x. Alright, it's going to be minus x squared. Alright, and that'll be basically take x, because the x and the negative 2x will cancel out. We've got 3, and that will become plus 3, so that'll be plus 6 dx. Right, so if you simplify that, then you can do the integral. So that's then going to be equal to minus x cubed over 3, take x squared over 2 plus 6x. Alright, and then we're going from 2 to negative 3. Alright, so let's just go through the algebra for this. Alright, so the first bit I've got to do my top function, that's going to give me 2 cubed, that's going to be minus 8 on 3. 2 squared, so over 2, it's going to be, work out to be minus 2. And then that's going to be plus 12. Alright, so that's my function there. Then I've got to take away, and I've got to put negative 3 into my function. So negative 3 cubed is going to be, or 3 cubed is 27. Because it's negative, it will be negative negative. So that will be 27 on 3. Right, and then it's going to be squared, so that will be take 9 on 2. And then that will be take 18. Alright, so looking for a common number, or in this particular case, because we don't have a lot of fractions, you could think this thing here has been negative 2 1/3. So if we have this over here, or maybe it's better to bring it all over 3 and bring over a fraction. So that would be negative 8, that's going to be take 6, and that's going to be plus 36. Alright, so that's an easy way of doing it by hand. And then over here, we're looking at, well, that's 9, isn't it? Okay, so again, we can bring this over 2. Alright, so that's going to be 9, so that's 18. That's going to be take 9, and that's going to be take 36. Alright, so then what we're going to have over here is it's minus 14 plus that, so that's actually equal to 22. Alright, and then that's going to be take, now that's going to give you 18, that's minus 18 minus 27, so that will become plus 27 on 2. So we could say that's equal to, if we wanted to, that's going to be 7 1/3 plus 13 1/2. Right, so we know that's going to give me 30. And then we start looking at the half plus a third. We know that's going to be equal to, that's going to be 2 plus 3 is going to be 5 6. Alright, so that is my area, and that will be units squared. Alright, so that's how you can do that. Now, obviously you've got a graphics calculator that does fractions easily for you, so you can do that. The main thing here that you'll probably have trouble with is making sure you don't lose the negative sign in here. Alright, so you've got to be really careful with that. Now, again, because we have a graphics calculator, right, we can check that value on there, can't we? Alright, so we can check that value using our graphics calculator. So if I went to doing that, I know that I could put this function into my calculator, and I could do that. So if I put that into my calculator, that should work it out exactly for me, so I can check to see that I've done it right. So again, we have to quit out of there. Alright, so the best way of doing that now would be to go to math, coming down to number 9, the if int. So we're going from negative 3, we're going up to 2, we're putting our function in over here, which is going to be negative x squared, take x plus 6, and we're doing that with respect to x. Right, and when you do that, it should give you the answer that we're looking at there. And by the looks of it, I've stuffed it up. Actually, I have stuffed it up. Alright, so it's 7 plus 13 is not 30, it's 20. So again, you know, the idea of using your calculator is to make sure that you get the right answer. I mean, you know that I know it's 7 plus 13 is 20. Alright, so in terms of looking at that question, alright, if you have a brain fade like I just had before, the calculator is going to pick it up for you. Alright, so in terms of that, I would highly recommend that you check your answers certainly by using your graphics calculator. Now, so in terms of the questions that you've got to do, right, the technique is really quite simple. The steps that you've got to go through is you need to find the points where it changes from being the top function to the bottom function. Right, so sometimes you'll have a curve that will in fact change. So you might have a curve where you have a function going something like this. Right, so then you'll need to consider these points here, and then you'll need to consider the points that the fact that this function is a top function and that with the bottom function, and then it reverses. So that's really the key to these questions, is making sure that you know which is a top function, which is a bottom function, and these points of where they change. Anyway, good luck with those questions. Make sure you help each other, and if you need some help in class, make sure you catch up with me, and I'll talk to you very soon.